Well, hello there, and welcome back for more Advent of Code. So today we are continuing with day 17. And last time we managed to get both answers, actually. So I think if I run this now, I should have, the answer for part 2, which I have already submitted, and it is this number indeed. And yeah, this thing works fine, but there are a couple of things that I don't like, and I wanted to refactor this thing a little bit. So yeah, there are a couple of obvious things that I want to improve. I think the first one could be that this solution doesn't print both answers. So we should. That's maybe first thing we can fix. Let's do that. We can yank all of this code up to here, I guess. Yeah, I mean, it's gonna be all the solution, right? Yeah, sure. Let's grab all of this, and maybe Rust knows how to extract into function. Look at that, very nice. Let's call this thing. What are we doing? Like simulate rockfall. Yeah, sure. Or simulate. Let's call it run simulation. Run a rock simulation. We're gonna have the input, and we're also gonna have how many rocks we want to fall. So rock count, I guess, or total. How do we call this thing? Total rock falls. Sure. Let's call this thing total rock falls, and it's gonna be a 64 bit number. And then in the end, instead of formatting here, we are gonna return this number. And sure, this should return not a string, but I use 64. And here we're gonna format this thing. And the first run is gonna be for 2022, and the other one is gonna be for 1 trillion. So run rock simulation for that input, and let's do 1 trillion. Well, I guess you can, you can infer the type there, and here you need 2 placeholders, and this total rockfall. We are shadowing it here, so let's not do that. And let's run now and see. This should have been a safe extraction. Yes, was that my first answer? I think it was. Yes. Okay. So very good. I think that's very good. There's a lot of printing that I want to yank out and maybe convert this thing into a constant or something. But before doing all that yak shaving, there's another thing that I want to fix, that I would consider like a logic error here, which is that this is my actual input, but if we go to the sample input, this code doesn't run. Or I mean, it does run, but it will take forever to compute. And this is because in the sample input, one of the conditions that we are doing in this loop doesn't happen. So here we are looking for rocks. Whenever we make a rock fall, we are looking for rows that are complete rocks. It's kind of like in Tetris where you have a complete row of rocks. And only in those cases we know that the top, if that complete row is in the top of the chamber, and we consider the top of the chamber like the last 5 rows, for instance, then and only then we check to see if the top of the chambers from this cycle are the same as the last cycle, and all that cycle terminology, we were talking about that in the previous session, so I won't repeat myself too much. But yeah, basically we consider the cycle when we have the same rock index and the same air jet index, so we know that things are going to repeat the same way. And if the top of the chambers are the same, then we can skip a lot of simulation. But well, this thing doesn't happen for the sample input. So what I was thinking, let's first add these changes. So because this is a good refactor to have both of the answers. I was thinking to try something else that is, I think, pretty simple. Like, I have a couple of ideas how to do this. Let's go back to the actual input and print this case when we have the cycles. So okay, well, we are printing 2 of the cycles because we are running 2 simulations now. But let's take a look just at this output. Well, basically you can see that there is these are the top of the chambers, and you can see that there is a row that is completely full. I have a couple of ideas. Another option would be to check the top of the chamber, and instead of looking just for 1 row that is full, look for 2 consecutive rows that between each other are full. So, like, for instance, if this had these 3 rocks would be missing here, but would be present, or for instance, if instead of this rock being full like this, it had 2 holes here, well, it doesn't matter because the next row is going to complete that, and you know there's no way that a piece can fall through the top of the chamber to some lower level. So we know that the top of the chamber is kind of like complete and won't let anything fall through, and that's basically what we are looking for. So let's go back to the sample input. I don't know what I touched there, but I don't want the new line. Sure. And how can we do that? So here, instead of doing this condition, well, we can have the chamber top. Actually, we are converting this chamber top to a vector, but I think we can use a slice here. Yeah, slice it up and only allocate the memory for the vector afterwards. I don't know if that's I mean, I think that should work. Well, let's try to code what I just said. I think it's going to be a bit noisy, but how do we do that? We can do chamber top. Before we were caring about this min y and max y with the coordinates of like where the rock has fallen, but I think we don't need to do that. We can check all the chamber top and be fine with that. Yeah. I guess. Oh, here we were getting. Well, there's a lot of things we can fix, but let's just do things step by step. So we have to compare each 2 rows. So I guess we can use the function windows. There are no array windows, right? I don't know if this is unstable Rust. I think it is. Oh, array windows. Oh, it takes this as a const parameter. Sure. But is this, yeah, unstable? This is an unstable feature, so let's use just windows. And we are going to ask if any of these windows, call it W, I guess. And let's have, I don't know, row 1 and row 2, or I guess A and B. B this window 0 and window 1. Not the prettiest destructuring, but it's fine. And what do we want to do? I guess row A zip. Is there a zip function? Yeah. Because row A, I guess, should be a static array, right? Yes. Nice. There's a zip on arrays. We zip it with row B, and we are gonna. I don't think there is an all now. We have to iterate over this and ask if all of the columns have a rock in either of them. So let's call it, I don't know, call A and call B, or these are not columns actually, this should be cells, I guess. Yeah, cell A and cell B, and let's ask if cell A is a rock or cell B is a rock. And that's what I want to ask. And there are some problems because probably, yeah, this is a reference. We can fix that. Nice. Zip. Oh, it is an unstable. It is an unstable feature too. Well, I guess I can zip the iterators. Does this work? Can it be? This does work. I'm a bit suspicious, but I think it's fine. Well, I guess to make it consistent, we can zip the iterators themselves and have two references here. Yeah, that's good. So this is what this means, that the chamber top is sealed. Let's say. Yeah, so no pieces can fall through. So if it's not sealed, let's break. Let's break, just like this. And let's keep the printing to see if this actually works for the sample input. And yeah, it seems it did. Look at that. This is not a full row, but it is sealed on the bottom. That's very nice. 3068, 288, are these the right answers for yes and yes? Very nice. So this works for the sample input. Let's see if it actually works for the actual input. And let's go. Yeah. It seems that works very fine. Okay, so yeah, this thing works for both inputs, which I very much like. And yeah, this is kind of an okay solution, I think. We can probably get rid of all the printing. Get rid of these, and this is two nested ifs, but this is an if-let, so sure. Then what else is here that we might want to remove? Oh, this min and max wise, I think we are not using them for anything now, so we can get rid of these also. It should still work. Look at that, only 2 milliseconds to run all of that. Good. Good. There are other things that I probably want to fix here. Like we have a ton of mutable variables and state that we keep track of in this function, which I think we can simplify a lot, I think. Let's see. Well, one thing that we can do, I think, is to make these rocks, whoops, be just a static or const. Can you be a const? Yes. And can you be called rocks? Well, yeah, that makes this a little bit simpler. Look at that. Still the same answer. Okay, let's see. There is another nice refactor, or not nice, but something a bit crazy that I want to try out, which is to maybe represent the chamber as each row as a simple byte instead of an array of 7 bytes, because these are, you know, each row has only 7 columns. So with 1 byte we have enough to represent like either 1 or 0 to represent each chamber. And I think if we did that, well, it's not for performance reasons, or maybe a little bit for memory savings, but it's just to, you know, kind of golf the solution down to its minimal state, I guess. But we can think about that later. Let's try to first like commit a working solution that is more or less sensible. So what do we have? Cyclic height, we use this to determine when we have determined that we have a cycle and we jump over to near the end of the iterations. So that is fine, I guess. These yeah, we can maybe put these constant things on the top and keep the mutable things together. Rock iterator, jet iterator, the chamber, this cyclic height that we assign. This memo thing is kind of ugly, not gonna lie. I don't know if using a hash map makes a lot of sense. I think it might. But this thing, which it represents the top of the row, and it's like a tuple of three things. This I don't like very much. We can probably give that a name and put it into a struct. Sure thing. Yeah, let's do that. And I think with that, I would be alright with the solution. Maybe another name for this I variable, which I don't really like. So this is, instead of going from 0 to the total rock falls, maybe it might be a good idea to call this like remaining rocks, and start at the top and say while the remaining rocks is greater than 0, and do the thing. But yeah, let's see where we are using this I. Here, I guess remaining, we're gonna do the remaining rocks -1, and we are using this thing to consider, to understand like how many rocks, like how to calculate the cycle and advance at once. So when we memorize this thing, I think here we should have breaking out of the loop and not do the memo. Yeah, I'm pretty sure. Let's keep a break here, just in case. Because now we can record here the remaining rocks, but I guess it should be -1 because we have already fallen this rock here, I guess. Yeah, when we write the rock into the chamber. So we are now remembering how many remaining rocks there were. So the fallen rocks difference is gonna be how many there were remaining before minus how many are remaining now. So this, instead of last fallen rock count, is last remaining rocks. I guess we could call it last remaining rock count, but whatever. We can do this minus remaining rock, the current remaining rocks. You know what? All this minus or -1 is a bit confusing. Let's try to go without the minuses. Fallen rocks difference, yeah. Remaining falls is gonna be total rock to fall. Well, actually, here, yeah, we don't have to do this. We have the remaining rocks is the meaning of the thing we want. So remaining cycles is going to be remaining rocks -1 here, I think. Divided by the fallen rocks difference. Yeah, I think so. And here you're gonna do remaining rocks minus equals remaining cycles times fallen rocks difference. Well, I don't know if I did that correctly. That was some algebra there. Let's see. Well, the answer seems to be the same as before, so I think that is that was a correct refactor, and we actually needed one less variable here because we were computing how many remaining rocks we had. I guess instead of remaining rocks, we could call this thing remaining falls, or remaining, yeah, rock falls, just to be very explicit. And last remaining rock falls, something like this. Yeah, okay. And maybe, I don't know if I should give a name to this thing. Let's add these changes and see how it looks to give a name to this tuple. Or I guess convert it into a struct. So we have these things, and let's say type. Let's put this over here. Struct. How do you call this? chamber top memo. And let's call this chamber top. It's gonna be a vector of rows. I would also like to make this thing a static array, maybe, but we can think of that later. The second thing is the chamber height, a usize. And the last thing was the remaining rock false at that time, which is these. Okay, and here we're gonna make a hash map of these things, and we're gonna insert one of these with the chamber top, which is gonna be chamber top 2vec. The chamber heights, which is gonna be chamber len, and the remaining rock false, which is gonna be just the variable without name. Very good. And here we should be extracting this. Well, maybe we can say some memo, and here we can extract the things on that memo. Well, let's see actually if not extracting chamber top, memo chamber top. What are we comparing here? Okay. Memo chamber heights and memo remaining rock false. Okay. Yeah, I'm okay with not dereferencing or destructuring everything. Yeah, that even looks cleaner, I think. If we run, nothing should have changed. Yep, perfect. Okay. So with that refactor, I think this is already quite an acceptable solution for day 17. Let's take a look at a little bit inside of this code. Here we have the rock index and rock. Oh, it would be also nice if the rocks were like a constant thing or like a copyable thing, so we don't have to allocate like this. Should stop. Here we stop the rock. Yeah, okay. Okay. Yeah. There's one little thing here that's, well, no, it's okay. I was thinking about like maybe breaking early if the top of the chamber, if the chamber is not 5 rows height, maybe we can early break here. But this is fine, I think. Then we have our nice static or constant array of rocks, very nice. And the code to move the rock is also fine, I think. Yeah. This looks not the best of all codes, but it looks all right to me. Yeah, let's just go for a commit of this and have day 17 part 2 solution. Okay, and yeah, I think that's what I wanted to for sure do. There is a couple of there is one more refactor that I would like to try out, which is to use, as I said, single bytes to represent each row, but I will try that on another session, maybe prepare some mate and do that later. But if you have any, thanks for watching and see you next time. Goodbye.